Let's talk about one of the more interesting results that you get out of calculus, and that's the idea of L'Hopital's rule. This is probably the most remembered limit technique that students take away from calculus because it's so powerful. And that's this. If I have two functions, f and g, and I say, and I find that they're both differentiable, and I'm looking at the limit of f and g, I'm saying, all right, the limit as x approaches a is f of x over g of x. And if I try to plug that in and I get an infinity over infinity, or I get a 0 over 0, so if I get either one of these two indeterminate forms, what I can do is, instead of evaluating this limit directly, I can take the exact same limit of their derivatives. So instead of taking the limit of, f of x over g of x, I can take the limit of f prime over g prime of x. That's an incredibly powerful result. It involves something called the extended mean value theorem, and we won't go into the proof of that this time, but it's a really neat result that essentially says, look, if you get something indeterminate, just take the derivative of top and bottom and try to get the limit again. And if it works, great. But sometimes you may have to apply it multiple times. But either way, you can just keep taking these things derivatives until it gets you something that's a little easier to deal with. It doesn't always solve everything, but man, it is pretty sharp. So let's take a look at something that we should already know how to do now. This limit here, as x approaches 2. If I plug in 2 directly, I get 4 minus 10 plus 6. So I get 0. And on bottom, I clearly get 0. So we've taken a look at limits like these before, and the way we solved it was by factoring. We could say, okay, well, that's the limit as x approaches 2 of x minus 2, x minus 3, or x minus 2. Right? So then I can cancel these two terms because they're in common. So I have the limit as x approaches 2 of x minus 3. So I get -1. Okay, so it's simple enough, right? That's not a very difficult limit to calculate. But instead, let's apply L'Hopital's rule. Specifically for things like polynomials, it makes them so easy. So take a look at this using L'Hopital's rule. So instead of having to do any kind of factoring, I say, okay, I'm going to take this same limit. Since I know it's indeterminate, and again, it has to be indeterminate. If it's not indeterminate, then this could potentially get you the wrong answer. You say limit as x approaches 2. The derivative of the top is 2x minus 5. The derivative of the bottom is just 1. So if so this is just the limit as x approaches 2, 2x minus 5, which is 2 times 2 minus 5, 4 minus 5, -1. Wow, it's a pretty sharp result. And that's not only just for problems like these. Now this one, that's not that big a deal, right? You could do that factoring, but when you get to that nasty stuff with like square roots or even trigonometric functions, the fact that you can just keep taking derivatives to simplify what you're doing, oh man, it's really, really neat. And it's probably one of students' most enjoyable, if I can say that word, techniques that they learn, because it's so satisfying to be able to take a difficult problem and just be able to reduce it by derivatives. So we're going to do some more examples, and we're going to discuss how to take the different types of indeterminate forms and kind of cram them into something that looks like this. Because in the case of something like 0 times infinity, how do we make it look like this instead?